Hi, everybody. So welcome to the Kubernetes Conformance Working Group Introduction Shanghai Edition. I am Aaron Crickenberger, and this is...
I'm Zefeng Wang.
So Kevin, why don't you tell us a little bit about yourself? Who are you, and why are you here today?
So I'm from Huawei, and I'm leading the Huawei open source team working on Kubernetes and on other ecosystem projects. And I have done many times of the conformance testing and certification, Kubernetes certification from China. So I'm happy to share some of the experiences and the information about doing the conformance. Yeah.
Cool. And I'm Aaron Crickenberger, Senior Test Engineer for Google. My username is spiffxp on GitHub and Twitter and Slack and all the places. I started working on Kubernetes back before it went 1.0, pretty similar to the time that Janet started. One of the first things I worked on was setting up conformance tests for when Kubernetes was version 1.1 or 1.2. And since I joined Google, I've been involved in multiple special interest groups, including the special interest group for testing and architecture and releasing. And I've been really interested in how conformance tests are being used today and how we can improve the coverage of them. So with that, I wanted to walk you through a brief summary of what the goals of conformance are. So you heard Dan Kahn say at the keynote this morning that we feel that Kubernetes has crossed the chasm. And so we've switched from the mode of operation where we needed to grow the project aggressively and move really quickly. And we instead want to focus on consistency and portability. We really want to make sure that when end users operate Kubernetes, they're able to describe workloads in a common format and run them on any Kubernetes. You may have saw the slide this morning where Dan said there are over 70 different vendors who have had their offerings qualified to be certified conformant Kubernetes. That means that you should be able to take your workload or your application and run it on any of those 76 different Kubernetes clusters, and they should all operate the same way. In this way, Kubernetes is predictable and everything will behave as expected. We want to make sure that end users can rely on a high level of common functionality so that a full, rich set of features can be guaranteed to work across all Kubernetes clusters. I think I really liked the phrase that Janet used this morning when she talked about making Kubernetes boring. I think that that's what the Kubernetes project is working on from an architectural standpoint when she talked about API extensibility, container networking interface, container runtime interface, container storage interface plugins. But conformance is really how we keep Kubernetes boring. We need to make sure that as we add new features and evolve the project, that conformance allows us to gate all of that. So the Conformance Working Group, of which Kevin and I are members, set out to create a certification program to make sure that any Kubernetes cluster that passes conformance tests can be certified as conformant. We wanted to make sure this program set in place a process that made it very transparent and auditable so that end users could reproduce the results that vendors provided for certification. And we wanted to make sure that now that we've built this program on top of conformance testing, that conformance testing covers as much as possible and is as meaningful as possible. So the last time we talked about the Conformance Working Group was in KubeCon Copenhagen or KubeCon EU, and I wanted to give you an update on what has changed since then based on my involvement with the project this quarter. So in version 1.11 of Kubernetes, we somewhat stalled a little bit as we focused on other areas of improvement in Kubernetes and only really added 4 new test cases for conformance functionality. In version 1.12, we set to work in identifying and documenting the requirements for conformance tests which we'll walk you through in a conformance deep dive, and I can also share with you at my presentation tomorrow on Adventures in Conformance. Using these new requirements, we were able to add 22 new test cases. We also began to realize that for conformance testing, we need to be able to measure and chart and show our progress over time. Just adding new test cases is not enough. We must make sure that the test cases we add actually improve our conformance coverage. So we set about doing this by looking at API endpoints that were covered from various conformance tests by using Kubernetes audit logging functionality, which was added in Kubernetes 1.8. In 1.12, we set up the ability for end-to-end tests to set their test name as the user agent so we could see individual test cases accessing different parts of Kubernetes in the audit log. In version 1.13, we started to look at not just API coverage as caused by conformance tests, but also code coverage or line coverage of conformance tests. Christy Wilson gave a talk this morning on testing CRDs, and she talked about using code coverage with unit tests to drive progress. Conformance tests are mostly an end-to-end test-based framework, and so we found a way to take the code coverage you would normally use for unit tests by running Go test and apply it to end-to-end tests to allow us to see, once you have covered all of the API endpoints, what other functionality can you cover that's missing. We also took the image that is used by Sonobuoy, which Kevin will talk about, and made sure that that was no longer provided by a third party, but instead made a part of the project. Using this, we added 35 new test cases. Graphs. So that's what those numbers look like in graph form. I really like this chart because it shows numbers moving up and to the right. And selfishly, I joined the project around V112. So when I started, we started adding a lot more tests. Yay for me. However, if you look at the number of tests that Kubernetes runs on the whole, that's what this light blue line is. These are tests that are used to block the release. If these tests don't pass, the release can't go out the door. And there's so many more release tests than there are conformance tests. This to me says there's a lot more functionality that we're not testing for conformance that perhaps we could be. This chart looks like a lot of pretty colors and a lot of noise, but I want to break it down in terms of the API coverage, not just the test cases. So these are the total number of endpoints that are covered by the different tests. The darker colors are covered by conformance tests. The lighter colors are covered by the release tests. The point that I want to show you is that while consistently the release tests cover slightly more endpoints, they are all going up and to the right as we improve conformance coverage for each new release. The other thing worth pointing out is that these are all of the endpoints available. These are all alpha, beta, and stable endpoints covered by conformance. Conformance is really a guarantee that is applied to stable features. Stable features are guaranteed not to change over time, whereas beta features may potentially evolve or change, and alpha features have almost no guarantees at all, so it is not worth certifying those as conformant. Really, we are interested in focusing primarily on the stable areas for conformance, and that green line looks relatively good. If I flip this around from absolute number of endpoints covered to API coverage, you can see that the percentages are greatly improving. And again, even though the percentages are nowhere near 100%, the delta between our conformance percentage and all of those different release tests is actually not that great. So our conformance tests have done a good job at targeting specifically the APIs that we care about. If you want to find out more about what insights we gained from API coverage, including specifically which kinds of tests we've decided we want to write and add going forward, I encourage you to come to my talk, Adventures in Conformance, which I will be giving around this same time tomorrow. With that, I think I will hand off to Kevin to talk about the certification program.
Yeah, so the certification program is basically just a program to around the conformance test to certify whether a Kubernetes cluster or offering is a conformant one. So vendors can certify with CNCF whether their products are conformant. This program is launched last year in November, and now there are more than 70 platforms that has been certified. Okay. So for newcomers who want to participate in the conformance program, become a certified platform, I need to do follow the following instructions. So first, you need to, of course, determine what service or what offering you're providing, and then is basically just run self-testing against your offering, and then so that's the most technical step. And then if you are not ready in the certification program, you need to sign the participation form to Linux Foundation to sign up for this program. And then, of course, you need to submit the testing results and then get accepted. So you can basically just send a pull request to this project on GitHub. And then if the applicant is not yet a CNCF member, he may need to pay some fees. But the costs are the same that become a CNCF member. So the last one is just abide by the terms and the conditions. For the conditions that especially worth to mention here is that the first is the versions. So currently, the certification program only open for the latest 2 minor releases. For example, currently the available version for certification is 1.12.2 and 1.11.4. For the conformance period, that means after you get certified with the conformance, the timeline stay valid. The timeline that stays valid. So basically, it's 12 months after the release version that certified. And the platform must to keep a recertification each year with the latest 2 minor versions just mentioned above. So here's an example here. So one company gets certified with 1.17 last year at 2017. So 1.7, we know that it's released on June 30. So 1 year later, the latest 2 minor releases are 1.11 and 1.10.5. So on or before June 30 this year, this company need to recertify with 1.11.0 or 1.10.5. Or before 1.11.0 come out, this company could certify with 1.9.9. So another one is that the offering should be able to, and the conformance test results should be able to reproduced by the end users. And for the other more details, here's the link, and you can check it out. Okay. So here are some of the most frequently asked questions. So basically, the certification has no extra charge, especially for the CNCF members and non-profit organizations. For the commercial organizations that not yet CNCF member, they can whether join the CNCF or just pay the cost. So to run self-test, there are currently typically 2 ways to do. One is with kubetest, and another one is Sonobuoy. So to run with kubetest, you need to use these scripts. These need to be under Kubernetes directly, whether it's cloned from the GitHub or you can download with the releases. So another choice is maybe a little bit easier. You can use Sonobuoy. So this is a tool currently also recommended by default on the Conformance project page. Before beginning, you need to, of course, have your cluster ready, and you need to install kubectl and config the kubeconfig. And then you can easily run with Sonobuoy binary, or actually on the website introduction, you can enter with the online version to start the testing. And then you can just wait for the testing to be completed and check out the results. So I think that's all we have today. And any questions?
One thing I wanted to add real quick on the difference between kubetest and Sonobuoy before we get to questions. Kubetest is the manner that conformance tests are run by the Kubernetes project. We have a website called TestGrid where anybody is free to submit their results. And so we like using TestGrid to display conformance for certain offerings every day, every couple of hours, every day. The key difference is that kubetest tests your cluster from the outside, as if I was an end user. Part of what makes Sonobuoy so incredibly convenient is as all you do is schedule a pod on your cluster, and the pod runs the tests against the cluster from inside the cluster. And then you get the results out of it when it's done. Super convenient, really great. But sometimes we feel as though conformance is about simulating an end user's experience, and an end user may not necessarily live inside of a Kubernetes cluster. They're often accessing it from their laptop or the outside world. And so we really are trying to work to improve how conformance tests can ensure that they're run from outside the cluster. Sonobuoy also, like I said, relies on a third-party image that is it was started by Heptio. But that image actually wraps and bundles up a whole bunch of tests that are provided by the Kubernetes project itself. It's important to note that Kubernetes, the project, is in charge of writing the tests that define what Kubernetes is. The Sonobuoy basically takes those tests and makes it easier to run them from within the cluster. So today, it is much, much easier to run Sonobuoy, but we are working to make it easier to run other methods as well. So yeah, any questions? Lucas, a microphone.
Have there been any more discussions about profiles and what to do with that kind of thing, like security certifications, like all these?
There have been many, many discussions about profiles. They are ongoing. In fact, I am trying to work to see if we can schedule a session at the Contributor Summit in KubeCon Seattle to have a face-to-face discussion. So conformance is about the set of functionality that is guaranteed to work on any certified Kubernetes cluster anywhere, regardless of what hardware it's running on, what cloud it's running in, what architecture, how it was deployed, whether all of the nodes are bundled together or they're spread out everywhere. But we find there will be some functionality that is necessarily going to have to be different or optional or additional. And so profiles are the certification program's way of adding this. So think of it like you have core conformance, and then you could stack on a new feature, like perhaps I can run a bunch of cloud provider specific stuff. That is something that, a Kubernetes cluster that I'm running here on this podium with a bunch of Raspberry Pis wouldn't be able to do, but a Kubernetes cluster running in a cloud, probably you would want to make sure that Kubernetes cluster could talk to load balancers within the cloud, persistent storage within the cloud, do well with auto scaling. Those are optional features not available out of the box. And like Lucas said, security would be another thing. I think the biggest sticking point for us right now, another big example would be supporting Windows containers. So it turns out there are a number of pieces of functionality that differ between Windows and Linux. Linux is the operating system that Kubernetes was originally based on, and we assumed everybody would be running Linux containers all the time. And it turns out Microsoft has made it so you can run Windows containers as well. But things like file system permissions or I believe temporary RAM-based mounts operate differently in Windows than they do in Linux. So that's some set of functionality that even though on the surface they offer the same abstract capabilities, the way they're offered is slightly different. There maybe need to be a different set of tests that run on Windows than run on Linux, for example. That all sounds really complicated. Why don't we just shove that off into a profile? So the idea is you must pass the base level of conformance, but we may add additional things on top. The other key point is I really, really want us to have profiles be an additive-only thing. So for example, if I have my conformant Kubernetes cluster and I add a new feature such as Windows support, that should not remove any functionality that the cluster already had. Some other thoughts for profiles might be security, and security is a really interesting one because security could potentially prevent a lot of things from happening. You notice Kevin said Sonobuoy requires a kubeconfig with admin level access. And if I have a Kubernetes cluster running in an enterprise and I have it very secured, I probably don't want to give some random testing thing admin access. How are we going to work around that? This is more of a process discussion, I think, than it is a technical discussion. I do plan on talking about some of this at my talk tomorrow, but essentially we want to at least categorize the different tests to start figuring out what tests may belong in different profiles before we have the discussion of how many profiles do we need and how are we going to certify those. I have no idea if that answered your question, Lucas, but hopefully that was the start.
Yeah, it's a good start. Another thing we've been discussing, like every KubeCon or something, is also like beta features and alpha ones. Like, could you comment on that kind of plan?
So a long-term plan I have that Kubernetes, the project, has for conformance and stability in general is we'd like to put formal gates into how new features are developed and what it means for a feature to be called alpha versus beta versus stable. We have the architecture special interest group, and right now they don't have any formal measurements in place to say your feature must have this much coverage, your feature must perform this well, your feature must have this much documentation. And we want to get to that place. And one of the things we are planning on putting in place is if your feature goes to stable and it is not optional, it must have conformance tests. And there are a certain set of requirements that conformance tests must pass. So they can't be slow. They have to be dependable. They have to be fast. They have to be reliable. So it requires a certain level of prudence when you're writing your tests to make sure you're writing them well, not just copy-pasting a bunch of stuff and hoping it works. So we're planning on making that a formal part of the Kubernetes development process. We're not there yet, but we definitely are actively moving in that direction.
Yeah, thanks. So it would it be that kind of additive profile then? If, like, say there's one customer or provider that has only the GA APIs for a reason, only the GA APIs available to their customers, but there's also one that is a little more experimental, or like not experimental, but has beta features enabled.
Right.
There's the third that has everything because it's like on GC preemptible VMs or whatever.
Right.
So is it like beta is a extension profile to conformance, and alpha is like on top of beta?
It's something like that, although I would argue we probably would never do conformance testing for alpha features since they are subject to change so much. And I think beta it's possible, but more likely we're going to say that beta, you must have tests that are capable of being qualified to or promoted to conformance. I blanked on where I was going with the rest of that answer, sorry. So the key point, though, is regardless of which beta or alpha features any different provider has enabled, they still have to pass all the stable stuff. Turning on a beta feature should not break my stable features. This is especially tricky when it comes to, say, enabling certain admission controllers or changing the way your scheduler works with priorities or predicates. That can't break the conformance tests. So that's really the one guarantee we're trying to keep. If an end user codes their application to use nothing but stable APIs, it'll work even if the cluster has beta and alpha features on.
Right. Very well.
Any other questions? All right. Well, thank you, everybody, for your time. I hope this was informative. So there will be a deep dive on the Conformance Working Group tomorrow, where we'll get to hear about the challenges of running conformance in an environment where the network is not reliable or air-gapped or downloading images is blocked. And we'll get to hear more about how new conformance tests are written and developed and promoted. I also have my talk tomorrow, Adventures in Conformance, where I'll be talking about all of the tools and techniques that I developed to measure API coverage and code coverage of end-to-end tests, and then some of the specific tests or lessons that we learned as we went along the way. Yeah, looking forward to improving conformance coverage. Thanks for your time.
Thank you.